welcome you all for this presentation about myself. My name is Babu Samuel. I work for Siemens Healthineers at Princeton, New Jersey. So in this presentation, I am going to talk about how to design a big data systems based on the feature modeling. So as we all know that big data system has become very important driver for innovation and growth for various industries such as healthcare, especially where I come from. Statistics says that the data production will be 44 times greater in the year 2020 than how it was in 2009. And also, there will be a 650% growth in the enterprise data in the next 5 years. To meet the business goals by means of the valorization of the big data, the proper design is very crucial. The development of big data system is not straightforward. Sometimes the big data project might fail because of the lack of the selection of the technologies, as well as if you don't have a proper big data system architecture. So in this presentation, I will just quickly go through how you design a big data architecture based on the feature modeling or based on the domain-driven architecture, and also I'll quickly go through some of the architecturally significant requirements for these big data systems. If you see these are the three topics I'm going to go through quickly. If you see the domain system big data design, it mostly based on the feature model, which covers the common and the variant features of the domain, and also some of the design rules, which based on the requirements and the use cases, and also some of the non-functional requirements. When you consider the big data design, there will be a two part. One is the domain engineering, and another one is the application engineering. If you see the domain engineering, so we take a set of literatures as a knowledge base to derive this domain feature model and derive the design rules and derive the reference architecture. What is this domain feature model? For this domain feature model, we have to follow the domain analysis process, which includes the domain scoping and the domain modeling. As we all know that the domain scoping includes the definition of the domain, the selection of the domain, and also the goals and the stakeholders' interest. But in this case, the domain is the domain of the big data system architecture. But when you consider the domain scope, domain modeling, in domain modeling, mostly we use the feature model, which defines the features, the interfaces, and also some of the dependencies as a feature diagram. So we consider all these and put it as a feature diagram in the domain model. And how do you define the design rules? As we know that the design rules are developed based on the features and the feature constraints. And also we take the literature as an input to derive some reference architecture. We all know that maybe we all know that what is the reference architecture? The reference architecture is basically abstraction of the real architecture. According to Muller, architects can use the reference architecture as a guidance to create a concrete architecture for their organization, business context, and technology. If you take the literature review based on the set of papers or set of the previous literature, or you can say, take the set of previous applications, there are some important observations about this big data architecture. So big data systems, if you consider, there will be a core components. So the core components contains some parallel batch processing engine, some distributed file system like HDFC, the Hadoop distributed file system, and NoSQL database. In addition to these core components, there are some additional components includes the querying engine, predictive analysis engine, statistical analysis, like machine learning engine, and data importing engine. Suppose if you use the real-time data, there must be some streaming or complex event processing engine. When you consider the architecture principles, these are all the architecture principles you have to consider: the loose coupling, cloud computing, and the scalability. When you consider the best practices, most of the big data system architecture is a data pipeline approach. What is this? The data pipeline approach is your big data system is a pipeline through which the data flows. In contrary to that, there is another approach called the data exploration and recovery. So in that approach, the data remains as it is in the source, but it is approachable for analytical purposes. So you no need to import or you no need to retrieve the data from the source. So the data is remain as it is in the source, but it is approachable easily and for the analytical purposes. But most of the big data system follows this data pipeline approach. Another important observation from this literature review, the more consensus about the hardware and software than the principle and the best practices. This indicates that how important the technology we use in the big data architecture when compared to the principle and the best practices. When you take this, suppose if you take that Hevner's information system research framework, if you consider that there is a two-part, one is the knowledge base and another one is the business needs. If you put everything together, take the knowledge base and take the business needs and then take some kind of architecture, this would be the big data architecture. This is the reference architecture for the big data. This contains the data, data storage, information management, and then the data processing, data analysis, and data visualization. I'll quickly go through the future diagram of all these components quickly. When you consider the data, this future represents the variety of data based on the storage, based on the state, and based on the representation of the data. Say, for example, in our case, we use mostly the DICOM, the medical data. So it could be in the form of DICOM or NIFTY or some MHD or HDR format. So in your applications or in your domain, the data format may be different. So if you put this as a modality and also the security, in our case, the data may contain some patient information. So we may need to anonymize the data. So it could be either anonymized or unanonymized data. And also we annotated the data for processing. So you can categorize as whether the data is annotated or not annotated. So this is the data. When you consider the data storage, these are all the important things you need to consider under the data storage. The indexing module, the data model. The data model could be either the key value data model or the document data model. You just put whatever is applicable to your domain or in your application. And then suppose if there is a variety of data, you should have this metadata management model. Metadata management which could extract the metadata or store metadata and access the metadata. And also you can choose the database based on the data model. Next, if you see the information management, this feature represents the governance of data in terms of security, privacy, data integration, and also the data quality. As you saw in the diagram, this particular component, the information management, isolates the data storage from the data processing so that the data is ensured of resilient to the changes. Suppose this is where you put your security and privacy, everything in under this. So there is a staging layer. Suppose if you want to use the real time, you should have the data acquisition in this. All the security and the privacy is under this. And also, if you see the data processing, one of the important features of this data processing is the data ingestion, where the data is acquired and then processed in advance for the later use. One of the important example is the pre-processing. Suppose if your data is already compressed, If you want to uncompress the data before processing, you can do that in this layer. And also the data analysis contains whether it is a high level or the deep analysis. The next one is the data visualization. This visualization provides the acquisition of data to the user and the application. So these are all the feature model for the different components of the reference architecture. Next, if you apply the design rule, so according to the design rule definition language, so you apply this formula. If feature is selected, then action on that feature on that node. For example, if multiple data types is selected, then load the metadata management on component data storage. Similarly, if the key value data model is selected, then load NoSQL on component data storage. If streaming is selected, if your data is real time, then load the data acquisition on the component information management. So you can put set of rules like this to bring up your application architecture for the big data system. Next, I will go through some of the architecturally significant requirements. So one of the first one is if you see that the database, the big data definition, it is defined as the 5 V's, that is volume, velocity, variety, veracity, and value. So these have been the items, these items have been the driver for the big data technologies. For example, if your data, the velocity is the property, the variety is the property which spawned the development of the NoSQL database. So this properties creates a new technologies. The next important property and the next important requirement is the hyperscalability. I don't know how many of you heard about this. The scalability is the term widely used in the software world, but there is a hyperscalability. What is hyperscalability? Suppose if you exhibit the exponential growth in the computer, the components and the resources, while exhibiting only linear growth in the operational cost, like to build, run, and also the manage the resources. For example, if you want to improve your storage, or if you want to improve the CPU process and the processing resources, so you automatically, when you improve these components, obviously you need more operational cost to build and operate and also manage these resources. But in the case of hyperscalability, if there is exponential growth in the computer resources, but only the linear growth in the operational cost, how this can be possible, how we can achieve this by doing the automation is one of the principles you apply to get this hyperscalability. You have to build the build and automate testing that will automatically that will also apply to this hyperscalability. The next one is the optimization. Even the simple optimization, if you do, that will improve the significant improvements in the cost saving in terms of the hyperscalability. For example, if you have a web server layer, if you optimize this web server layer, for example, instead of providing 1,000 web servers, if you reduce to 900 to meet the same request, then obviously you are reducing hundreds of web servers to meet the same request. So the operational cost is less as well as the maintenance cost. Even in the algorithm level, if you optimize your algorithm, for example, if your algorithm is the linear or nonlinear complexity, so obviously that will improve the performance by reducing taking less number of resources. So that will improve the hyperscalability. So the third principle is the optimization, and the fourth one is even the simplification is another principle you can use to get the hyperscalability. What is simplification? Even the simple solutions import the scalability. For example, in the case of a database, if you use the relational database, the consistency, you get the most strong consistency. If you want to trade off the consistency with the scalability, you can use the NoSQL database. And also the stateless server is another example where you can get the hyperscalability. And the another one is, huh? Okay.
All right. So thank you, Babu.